Hello, everyone, and welcome to Spill the Tea. We are the STEMComm team from Georgia Tech, and we write articles about science to improve accessibility, and we make videos about women and people of color in STEM. And today we're going to be showing you several cool experiments that you can perform at home and explaining some of the science behind them. You will learn how to make a mug cake, how to make butterfly pea flower tea. You'll see how you can calculate the speed of light by melting chocolate in a microwave. And you will also see what spherification is and how it works. Some of you have ordered materials, so you can follow along with us as you go. And we'll be pausing briefly after each activity to give you guys extra time. But the session is being recorded, so don't worry if you don't remember everything, or if you don't currently have the materials. You'll be able to rewatch it at a later date. And if you have any questions, please ask them in the chat and one of us will try to respond to you. So with that being said, we will go to our first activity, which is the butterfly pea flower tea, and I will let Lena and Cassandra talk to you about that.
Hey everyone, I'm Lena Harpy. I'm a second year chemistry student at Georgia Tech, and me and Cassandra will be guiding you guys through the butterfly pea flower today. Say hi, Cassandra.
Hi, I'm Cassandra Lund. I'm a third year computational media student at Georgia Tech.
So let me give you a quick introduction about butterfly pea flower and what it is and what it does. First of all, let's talk about pH. pH is a scale that measures how acidic or basic a substance is. It measures the concentration of protons using a certain equation to give us a number from 1 to 14, 1 being the most acidic and 14 being the most basic. And there are substances that are called indicators. Indicators change color in response to acidity or alkalinity, and they do so by binding to the hydrogen atoms that are available in the hydrogen protons in the substance. So for example, butterfly pea flower has a substance called anthocyanine. Anthocyanine, if protons are present, it binds to them and changes color and becomes more pink. But if a substance is basic, it will turn into a yellow or green color. So now Cassandra will demonstrate how to make the butterfly pea flower.
All right, so you're going to want to have your water boiled before you make your tea, obviously. I did that before the event, so it might take you a few minutes to put it in your kettle or wherever you're boiling your water. So I'm gonna see if I can get my camera looking at the right spot here, and it's not cooperating super well with me, so let's see. Okay, I'm just going to bring it up here then. So what you're going to do is you're going to take your butterfly pea flower tea, and it does need to be butterfly pea flower tea. It's the specific chemical in the butterfly pea flower tea that does do the indicating and change up. Just enough for 1 glass or however much you want to make. It doesn't have to be very much water at all. So you're going to take your tea bag, going to take your glass. I mean, you usually make tea in a mug, but I don't have any clear mugs, so a glass works just as well. Then you're just going to pour the boiling water over the tea. So you've got your bright blue tea here. You can sort of stir it around a little bit, but you don't need to leave the bag in at all for very long. This stuff's real strong. And that's all you're going to be doing to make your tea. And we'll be seeing how it changes color later.
Okay, so we're going to continue on to the next experiment, which is calculating the speed of light with chocolate in a microwave, and I will let my teammates take it from here.
Okay, hi, I'm Sabrina, and I'm a 4th year computational media major at Georgia Tech. And I'm going to be explaining what a microwave has to do with the speed of light. So first of all, microwaves and light are both types of electromagnetic waves. And these energy waves have different wavelengths, so they have different properties. So microwaves are actually the longest type of electromagnetic wave, and you can't see them, but many electronic devices like TVs and radios and even your microwave can sense them and use them. And visible light is shorter than a microwave, and your eyes can see these type of wave. And even though the electromagnetic wavelengths, they have different wavelengths, they all travel at the same speed, which is the speed of light. And now Alyssa will talk more about how the microwave works.
Hello, I'm Alyssa. I'm a first-year physics major from Georgia Tech. So the big thing about the microwave and the chocolate for finding the speed of light is you can use the microwave as it uses microwaves to heat up your chocolate. The microwaves will go through the chocolate and the energy is what makes it warm up and melt. Because the waves have different amounts of energy in different areas though, your chocolate is going to melt at different speeds. So where the wave is cresting or at a trough, you're going to see it melt faster, which means your chocolate won't melt evenly as long as your microwave isn't, as long as the tray isn't in your microwave spinning. This means that you can measure the distance between these spots to find how long the wavelength is and use an equation to find the speed.
Hey everyone, I'm Tyra Newton. I'm a fourth year mechanical engineering student at Georgia Tech. We only need two pieces of information to find the speed of light. We need the wavelength, as mentioned before, and the frequency of the wave. The wavelength is the distance between two consecutive wave peaks or troughs. In this case, it's the distance between the two most melted points multiplied by 2. And the frequency of the wave is how many waves are observed in 1 second. And you can find this somewhere on your microwave, whether that be outside or somewhere inside the microwave. We can find the speed of light by multiplying the wavelength and the frequency of the wave together. Now, Lena will be showing you a demo of this activity.
Hi. So first of all, we should be removing the tray. We don't want it to be spinning. So take out your tray. Get a plate, put it upside down, and then put your other plate on top normally, just to prevent it from spinning. Get your chocolate, open that. Place your chocolate with the shorter side facing you, so this way into the microwave. And run it for about 20 seconds, and then we'll start measuring. You're gonna find 2 lines on your chocolate. I don't think they're visible over here, but you're gonna get a measuring tape or a ruler or any kind of measuring device. And you're gonna measure in centimeters the distance between the 2 lines. So mine, for example, is around, I would say 6 centimeters from here to here. And Tyra is now gonna tell us how to do the exact math with the measurements we got. So yeah, I got 6 centimeters. Let us know in the chat what you guys got.
So yes, the distance between the 2 points should be around 6 centimeters, and the frequency of your microwave should be, standard models are about 2.45 gigahertz. So what you do is you multiply, make sure that you first convert your units into SI units. So convert your centimeters to meters and your gigahertz to regular hertz, and multiply those together, and you should get a speed of light of around 299 million meters per second.
Hello, everyone. Okay, so the first step for the mug cake. My name is Deviani, and I am a second-year computer science major. And my favorite science topic is about space, as you can see with my NASA shirt. Today, we'll be showing you how to create a chocolate mug cake using only the microwave. And the first step is to get your favorite mug. Mine is a ladybug one. You can use any mug you want. And I'm going to pass it off to Elena and Aparna, who will explain the science behind it, and they can introduce themselves.
Hello, my name is Elena Cabrera. I am a first-year psychology major. I'm from Sunrise, Florida, and my favorite science topic is social psychology. And I'll pass it on to Aparna to introduce herself.
Hi, my name is Aparna. I'm a computer science major from Alpharetta, Georgia, first year, and my favorite science topic is quantum computing. And I'll pass it back on to Devyani.
Awesome. So the first thing you're gonna need is you're gonna need 4 tablespoons of flour, and then you're gonna need 2 tablespoons of some good old sugar. You're gonna need half a teaspoon of baking powder, and you're gonna need 4 tablespoons of milk. It could be any milk. You can use soy milk or almond milk or any kind of milk. And then you're gonna need 1 1/2 tablespoons of oil. And then you're also going to need 1/4 teaspoon of vanilla extract. This is optional. If you have it, you can put it in. If not, it'll taste just fine. And then lastly, you're gonna need your chocolate chips to sprinkle inside the mug cake. So I'm going to show you adding all the ingredients. I don't know if you can see my mug, but you're gonna mix in, while I mix in the flour and the sugar and the baking soda, Aparna or Elena, do you mind explaining the science behind it?
Yeah, so starting off with the cake batter. So when the cake batter is heated, an alkali such as sodium bicarbonate and an acid like the cream of tartar that's in the baking powder will react to produce the bubbles of carbon dioxide, which causes the cake to rise. And then of course, the cake would be nothing without being sweet. And this is provided by the sugar along with the optional chocolate that you can add. And I'll pass it on to Aparna to explain some more things.
That is awesome. So I'm going to add the 4 tablespoons of milk and oil and the vanilla.
Yeah, so the main body of the cake comes from the flour and the milk. So having both the flour and the milk mixed together causes some of the proteins in the flour to form an elastic network of proteins called gluten. If you're using gluten-free flour, the rice or starch in the flour serves for the same function. Heat causes the rubbery gluten to coagulate into a strong structure, which makes the body of the cake.
That is so cool. I did not know that. So I'm going to stir in a little bit of vanilla. And then now I'm going to stir. You can either use a whisk or just a regular fork and just mix everything in. You can either add the chocolate chips within your cake batter right now, or once the mug cake is done out of the microwave. But I'm just going to go ahead and sprinkle some in here right now. Once you have everything stirred and added your chocolate chips, you're going to put it in the microwave for 45 to 1 minute. So I'm going to put it on for 50 seconds, which is a happy medium. So, and we're going to wait until it's done.
And while we wait for that, I can explain something else that was pretty cool. The purpose of the oil that was put into the cake is that it coats all of the ingredients to prevent you from having a dried out cake.
And of course, the energy provided by the microwave oven allows for several chemical reactions and physical changes to happen, finishing the cake.
There's 15 seconds left.
This presentation may have been a little fast, so be sure to check out the mug cake recipe link, which Sabrina put in the chat.
All right. So when you look inside the mug, the cake should be firm to touch. So you could just use the fork and lightly tap it to make sure it's firm. This is what it looks like for me. And you can dig in and give it a taste if you want. Now, it might be a little hot, so you might want to blow it a little bit. And if it's not cooked all the way, you can zap it in the microwave for another 10, 50 seconds. But yeah, I hope you all enjoy it.
All right, I think you guys know the drill by this point. We're just gonna wait a little bit because it seems like a lot of you were struggling a little bit to get all the ingredients ready. So I'll pause for about a minute so you guys can check out the recipe that's been reposted in the chat so that you can get all of that set up. And then we'll move on to our next activity. All right, cool. So for our next experiment, my teammates are going to demonstrate a molecular gastronomy technique, which is called spherification. Angelique and Claire?
Yeah, hello there, everybody. My name is Angelique Laboy. I am from Puerto Rico, and I'm a fourth-year computer science major. My favorite topic has to be color. I just love the fact that pink is not really a color. But joining me today is going to be Claire. So if you want to go ahead and introduce yourself.
Yeah, hello everyone. My name is Claire Deng. I'm a first-year neuroscience student, and I like color too, but I also really like squishy things. So spherification is a really interesting thing that you're going to see today. If Angelique wants to kind of kick us off.
Yeah, okay. So we're going to be doing this dynamic back and forth. She's going to be explaining the science. I'm going to be doing the things. So to start off, I need you guys to get a cup and just fill it with warm water. You probably cannot see it because it's black, but here's the water. And then you're going to get, if you did get a kid, there's this tube that is kind of like powderish, and it says ALG on the top. This is sodium alginate. And so I need you to basically just pour it in, right? And you're gonna stir it, whether it be with a whisk or whether it be with a fork, it does not matter. You just need to go at it for a couple of minutes. So while we're doing this, it's gonna form like this gel type. Claire, can you tell us like a little bit of why it does that?
Yeah, sure. So sodium alginate actually comes from a seaweed, and sodium alginate is also used to make agar-agar, which you might find in some like gelatin alternatives. Basically what it is that it becomes a gel. And the way that it does that is by this process called polymerization. So you have monomers and you have polymers when you're looking at like very, very tiny like particles that everything is made out of. So monomers are like the smallest particle. So if I have this marker here, these two are monomers. If you connect them together in a process called polymerization, they link up together. So if you have all these particles that all link up together, they can form these really big chains. And that's kind of what you're seeing in this alginate. But sometimes it happens a little bit slowly. So if your gel doesn't start to form immediately, don't get frustrated. You just got to start a little longer.
Yeah, that's basically what's happening here. So this is basically supposed to take like a little while. So continue doing it. If you have like a friend or a family member helping you, then I would consider having them still do it. Because right now it's gonna be like whitish, but you're supposed to like just fully dissolve it. So in the meantime, I need you to get a cup of water. This is gonna be so then at the end we actually put like the pearls in, and it takes out this like salty feeling to it. But so water, I filled it to the half or something, doesn't have to be accurate. And then next I just took like 1/3 of a cup, can be any type. And again, if you did order the kit, you're gonna have this like real lemon juice. If not, I know that like people have like those circular ones. That also is gonna be useful here. You're just gonna pour this in, and you're gonna mix it with the other two, which is CaCl, calcium chloride. So Claire, calcium chloride, what is it?
Yeah, so calcium chloride is what we in chemistry call a salt. So it's not a salt as in table salt, so don't eat it. But the thing about salts is that when they're inside water, they can break apart very quickly. So the calcium and the chloride separate from each other in water. And so that's how you might be able to tell that this calcium chloride is going to dissolve in the water a lot quicker, because what's happening is the water molecules are kind of pulling them apart.
Awesome. Okay. So while she was explaining, I was making sure to just like put it in, right? I'm just gonna lower myself here so you guys can see me. So we had the obviously like the lemon and then also the chloride. So now I got this other thing. You're just gonna mix it. right? You're gonna mix it until you don't see anything. Like you know, like if they were like very tiny like circles, you're not supposed to see them. So that's when you know like it's fully like done or dissolved in this case. And at the same time, if you have two hands, then like you do the other one and you keep mixing it. And then, but just because it's gonna be a while, just a few seconds or minutes. Claire, tell me a fun fact about spherification.
Yeah, of course. So spherification has been a technique for a long time, but it was popularized by this French or by this Spanish chef. And if I butcher this name, I'm very sorry. But his name is Chef Ferran Adrià. And this chef, what he wanted to do was he was really interested in how spherification works. So spherification is when there's like this membrane on the outside of this liquid. And so if you like bite into this seemingly solid thing, it kind of explodes like a water balloon. And inside you can put juice, you can put purees. And so there's a lot of things that you can cook with this spherification method. And what this chef did was that he was really interested in recreating caviar. So if you guys know what caviar is, it's basically fish eggs, you know, the little round things. And he wanted to recreate it using juice. And so he would be able to kind of like how we're using lemon juice here, he would use like orange juice or mango juice to make these tiny little spheres. And they would look like caviar and well, they wouldn't taste like caviar, but he would be able to use it to make things like fake sushi that's all made out of sweet things. So a very interesting technique. If you want to read about it, there's like a lot of really interesting dishes that he made.
This is so cool. We see some people that cannot make it. It's fine. This is some weird like mixture. So it's not that you find it in the grocery store, but you can watch me do it in the meantime. Okay, so I think it's pretty solid. I know some of you might still see some clumps in the one with the water in it. The other one for me is like fully dissolved. If you go ahead, this is really fun. You can touch it and it should kind of feel like gelatin or like jelly or something. If you're doing them, then you're in the right step. If not, just continue mixing for a while. So while continue mixing here, you're gonna need, what is this? Oh, here. So the whole point, right? If you guys have had like boba tea or anything, they are spherical, hence the name, right? So I don't know if anybody has any syringe, you can use that, but in this case, I have a tablespoon. This is like the smallest one that I have. I know there's a smaller one. This is 1/2 tablespoon. And here, after you completely mix it here, you're gonna take your lemon, which is this thing inside, and then just pour it in. So that way, when you put it or bathe it in the sodium alginate, it kind of creates this like circular form, spherical form. So you just put it in. Ta-da. I do another one because why not? There's still some remaining. Boom. And then like, sadly, I don't have the greatest camera with my computer here. If it was like one of those like camera, I can be like, yo, look at this. I can do the microscope look of it. So for me, I see like something dissolved-ish with the yellow thing here. So you can go ahead and like mix it a little bit. Just continue doing that. And then at one point, very carefully, you're supposed to take it out. And then remember that thing from the beginning, like the cup? I'm just gonna put it in. Yes, I I did wash my hands before this. So thank you, Dr. Levy. What else? Because yeah, the whole point of this is that you can actually eat it after it's done, or you can put it in your tea. You never know. The last step. Okay, so basically, I have this like tablespoon here, right? And then you have the lemon. So you just pour it in. I don't have any more, so I'm gonna pretend it. It's here, and then I just put it into the one that had like the sodium alginate and the water, and just put it in. And then you continue mixing it, and then eventually, very carefully, you're supposed to like extract it, and then put it into the water so it doesn't taste like salt. So I'm gonna try doing this. Did it several times. The results sometimes can be different.
Do you want to try using the spoon?
I I can do that too. Find a spoon. Okay. Here's a spoon. Oh God. Anything else that you would like to tell us about this? A fork also works in this case. Claire.
Yeah, so spherification, again, we just used lemon juice here, but you can use pretty much any kind of fruit juice or any kind of puree. So if you ever want to try it out, you can buy sodium alginate at a store, and you can try it out for yourself. There's lots of really interesting recipes that I found on YouTube when I was doing research about this, and they all seem kind of complicated. But as you can see here, you can go for a really basic one, and you can kind of make your little jelly things.
Yeah. So I had too many of these before. No, you cannot see it from like the camera, but you can go ahead and try it by yourself. I hope it tastes amazing. Did it many times. Yeah, like how Dr. Levy says, is lemon juice is clear. So that's it for us. Thank you. Yes, if you wanted, well, yeah, if you wanted to, you can like put the spherification in here in the tea. I don't have the tea, but thank you so much for this. It's been amazing. Claire, thank you so much for the science behind this. And like Ricardo, you can take it away.
Thanks, guys. That was really cool. So we're gonna probably just wait about 30 seconds. There are several questions that have been asked in chat that we're addressing about the activity. And after that, we're just gonna finish with the tea activity from the beginning. All right, so we're gonna wrap up the tea activity now. Cassandra?
Hello, hello. So about the spheres, you can eat them, or you can put them in your tea. If the spherification didn't work for you, that's why we included an extra packet of the lemon juice here. So the good news is you don't actually need the spheres to make the tea change color. You just need to change the pH, or you just need the acid. So just adding a drop or two of lemon juice will also do the trick. The spheres are fun, but they are not required for this part. So if you also struggled with that, good news, you're still going to have success here. So we're going to look at our tea. It's like a bright blue right now. It almost looks like Windex, which is kind of disconcerting when you drink it, but it's fine. It's not Windex. It just looks like it. And then all we're going to do is add a little bit of the lemon juice. That's probably too much lemon juice. I'm going to regret adding that much, but that's okay. It will still look good. And you can watch it sort of change color in real time. I'm going to grab my fork, and that's going to make it change color faster. We're just going to swirl it around, and you're going to watch it go from like a blue to like a purple. My camera is not doing a great job of picking up this color change. I am disappointed to admit, but unfortunately that is the computer camera that we are constrained by. It's a much more purpley color in person. But that's the color changing tea. I recommend adding sugar or something to it, because if you just drink it as is, it's very acidic, because we just added acid to it. Oh, that's good. Maybe it's working better on your screens, because on my little screen, it didn't seem to change too much. But yeah, the purple color is really nice. Like, I was surprised at how nice it was when I did it for the first time. I think that's our color changing tea demonstration, Ricardo.
Awesome, thank you. So we are going to post a link to a survey in the chat shortly, and we'd really appreciate if you guys could fill that out. And we'll just give you a little bit to do that, maybe wrap up some of the activities. And if you have any questions, please place them in the chat, and we will go over them in a little bit. So once again, the survey has just been posted in the chat, so if you could spend a little time doing that, we would really appreciate it. Thank you.
I'm gonna try and make it in front of you guys. Maybe my camera is gonna be a little bit more clear because I have like the light right on top of me. So I have an actual lemon, and I wanna. Yeah, I think that's a bit more clear for the color. Yeah. Sorry about that.
All right, so once again, we are the STEMComm team from Georgia Tech, and you can read the articles that we write about science on chargedmagazine.org. We will post the link to that in the chat. And you can also see some of the videos we've done on YouTube, and I believe one of my teammates is going to put that on there as well. So once again, the talk will be posted, so feel free to rewatch it if you need to go over some of the steps. And please fill out the survey. And thanks everyone for coming. I hope you all have a great night.